The sheer mass of a pyramid dominates the desert floor, an architectural presence that forces us to reckon with the limits of manual labor. Looking at the geometric precision of these monuments, it is easy to assume they require modern lasers, advanced heavy machinery, and complex math to construct. Because of that scale, 19th century scholars convinced themselves the ancient architects had secretly encoded mathematical constants, like pi and the golden ratio, directly into the stone. These calculations projected an image of an ancient society wielding abstract theoretical wisdom that was eventually lost to time. Here is the core discrepancy. The physical execution of the stones is flawless, but the archaeological record is entirely empty of the advanced formulas or heavy machinery we assume would be required to build them. The flaw in these popular theories is straightforward. The ancient Egyptians simply did not use our mathematical systems. Rigorous architectural history has dismantled the idea of hidden codes, proving that early researchers were projecting modern formulas backward onto ancient designs. Raising stone toward the sky required immense, gritty labor and tangible ground-level geometry rather than abstract equations. The evidence points away from magical numbers and toward a profound mastery of practical physics. Searching for lost technologies obscures the reality of how they built these structures. They relied on human ingenuity, leveraging the natural environment. The first logistical hurdle is the landscape itself, moving colossal granite blocks across miles of high-friction desert sand. One answer survives in a Middle Kingdom wall painting from the tomb of Jehuti-Hotep, which details 172 men hauling a multi-ton statue on a wooden sled. At the very front of that sled, a single individual pours liquid directly onto the ground. For decades, historians categorized this detail as a minor ceremonial gesture. Physicists at the University of Amsterdam recently tested this exact action in a laboratory setting. Pulling a heavy sled over dry sand causes the grains to pile up, creating a wall of resistance. But adding a precise amount of water ahead of the runners makes the surface firm. The moisture creates microscopic bridges between the sand grains. This stiffens the surface and halves the pulling force required to move the load. Redefining a supposed religious rite as a calculated manipulation of friction transforms an impossible transport problem into a solvable engineering equation. The next challenge is achieving symmetrical slopes without using trigonometry or our modern degree system. This diagram illustrates the ancient concept known as the seked. To calculate the slope of an oblique face, builders started by measuring a vertical drop of exactly 1 royal cubit. They then measured outward horizontally using smaller units called palms. Connecting the top of the cubit to the end of those palms yielded a diagonal slope that was easy to repeat. To establish perfect right angles on the ground, they used long measuring cords knotted at specific intervals, laying out 3, 4, 5 triangles in the dirt. Surveyors took these knotted cords and cast massive square grids across the site, ensuring an aligned foundation before the first stone arrived. This structural perfection was the result of physical repetition and tangible measurement, proving that complexity arises from compounding simple physical actions. This reliance on practical physics extended beyond stone architecture into their material science. At the ruins of Tel El Amarna, excavations revealed the world's earliest known glassmaking factory. Early archaeologists, including Flinders Petrie, struggled to explain how workers produced such pristine glass in antiquity. Modern experimental archaeologists reconstructed these ancient furnaces, demonstrating that achieving this quality required pushing primitive fires to extreme temperatures through industrial-scale trial and error. Whether laying a 50-ton monolith or forging delicate glass, their capabilities were driven by repetitive iteration, not alchemy. Standing inside these spaces today, the volume of the environment reveals a deep understanding of load, balance, and material limits. The projections of pi and the golden ratio disappear when placed next to their actual instruments: knotted surveying cords, wooden rods, and the application of water. We are naturally inclined to search for complex patterns when confronted with something of this scale, but the real secret of ancient Egyptian engineering was a relentless observation of the physical properties of their environment. The evidence reveals that these structures were not born of magic, but of human hands using the simplest materials, sand, water, string, and stone, to create a permanent mark on the landscape.